So just like the sig figs, there are rules that go with scientific notation. But luckily, where sig figs, someone just made it up as they went along. Scientific notation is math rules. Okay? So if you've done this type of stuff in math, this is exactly what you did in math. Okay? So multiplication, what you're going to do is you're going to multiply the c's, the numbers, together to get a new number. So that's 4.0 times 1.5. And then what you're going to do is when you multiply exponents, you add them. Okay? In this case, it's positive 6 plus negative 3 equals what? 3. Positive 3. Okay? And 4 times 1.5 is what? 6. So we have 6.0 because that has 2 sig figs, that had 2 sig figs, so our answer has 2 sig figs. 6.0 times 10 to the third. Okay?
So, wait, so that's what we got out of all that?
Yes. So we took the 4 multiplied by 1.5 to get 6.0. Then we took 6, added negative 3 to get 3. It looks hairy, but you just break it down and it's very simple, right?
Oh, so the other side is just basically telling you what you did?
Yeah.
Okay,
Yes,
cool.
yeah, so,
Okay, I got
yeah.
it.
Division is the same idea. You take that number, divide it by that number. What's 4.0 divided by 2.0? 2.0. 2 sig figs, 2 sig figs. Your answer has to have 2 sig figs. And then when you divide by exponents, you subtract. Okay? So this is negative 2 minus 3 equals
Negative 5.
negative 5. So we have 2.0 times 10 to the negative 5. Everybody follow that? If we raise exponents to a power, we multiply them. Okay? You won't do this very much. Okay? You will multiply and divide exponents in scientific notation a lot. I don't know if you'll see this or not, but if you do it, you take that exponent and you put it on both things that are in the parentheses. Okay? So you get 3.0 squared times 10 to the 4th squared. What is 3 squared?
9.
So this is 3.0 times 3.0
9.8.
equals 9.0, right? Times 10, and here you multiply the exponents together. You get 4 times 2 equals 8. So you get 9.0 times 10 to the 8. Everyone see that? Okay. Here's some examples. This is multiplication, right? Not division. You can see that. So what's the first step of doing multiplication?
Times 6.78.
So you have 6.78 times 5.55, which is, anyone do it?
37.6.
I did
37.63.
37.63. Okay, how many sig figs do I need? 3. 3. So what is my actual answer?
3.7.
37.6. We don't have to change this in the scientific notation. Okay, so we can just 37.6. Now what do I do with my exponents?
3 plus negative 4.
Right. 3, multiplying, you add. So you have 3 plus negative 4 is,
Negative 1.
so you have 37.6 times 10 to the negative 1.
On the paper, you have 3.76.
Yeah, because you move the decimal, you can move the decimal and you have 10
And
to
then
the 0.
change that to 0.
Okay. Yeah.
So
So
we know the step.
Yeah, he just did what I
You
just
can leave it like
said.
that or you can
So
move it.
you could leave it like that. If this was on homework or on a quiz or something, you could leave it like that and I would mark it perfectly correct. What I did is I did change that sort of, I got rid of 10 to the negative 1. If I moved that decimal point to the left 1, I increased that exponent 1, it becomes a 0, this all goes away.
My, calculator already, it gave me 37.6, is that right?
37.6 by itself is not correct. It's
I
either
mean,
37.6 times 10 to the negative 1 or 3.76. Either one of those is correct. Let's go to the second one. So what's the first step here? Yeah, 2.99 divided by 4.03.
Times
E-
10, wait,
You can do times 10 to
to
the
the -9 minus 6.
negative,
Nine
the
minus
negative 9
negative six.
minus negative 6, which is negative 9 plus 6, equals negative 3. So what does this come out? 0.742. I think I heard 423. So how many sig figs should this have?
3.
3. That has 3, that has 3, so this has to have 3. So it is 0.742 times 10 to the negative 30. Everybody okay? Let's do the last one. What's the first step? 7 to the 4th times 10 to the 12. We took the 4, multiplied it by the 3 to get 12 as our exponent. And what is 7 to the 4th? 7? What is it?
70,000.
Right.
2401.
2,401?
Mm-hmm.
Yeah.
Okay. Times 10 to the 12. Okay. You could change this again to write 2.401 times 10 to the what?
No,
negative 3.
9.
9.
Oh, so you subtract 3, so it'll be 9.
We move to the left 3,
Yeah.
so we have to add 3. So it's times 10 to the 15th.
But either one would be acceptable.
Yes. Either one of those would be perfectly fine. Unless the question specifically said to put it in scientific notation. In which case you'd have to do that one.
After you move the decimal from the sign, to complete it, do you drop the scientific notation like you did over here, that 3.76?
In this case, I dropped it because what we actually have here is times 10 to the 0.
Mm-hmm.
So then I don't have to write that. Here, I have 10 to something. So I
Okay,
can't
so
drop it.
it's 37.6 times 10 to the negative 1. So you moved it to the left for 1, and then once you,
I added 1 to negative 1.
okay.
Because I moved to the left 1. I went from negative 1 to 0.
Mm-hmm.
And 10 to the 0 is 1. Times 1 doesn't do anything.
Okay, so are you supposed to like, oh no, never mind.
So in this case, you could put the times 10 to the 0 if you wanted. And I think I saw a couple faces when I said, if a question specifically wanted scientific notation, why would it be that one? Why is that not scientific notation?
Does it have that one?
Because it's not between 1 and 10.
Okay.
Scientific notation is not just this times 10 to
Is
the
it just
something.
in chemistry or period?
It's also in physics,
Okay.
but in real life, no.
Okay, that's why I was like.
Yeah.
Did I learn that?
When you translated the scientific notation and you went over to the left, since it's a positive, so then you're putting it, you change it to frequency, you're adding it, so if it was to the right, you would subtract that?
Yes.
Okay.
So say I had 0.2401 times 10 to the 12. I would move it to the right 1, so I'd have 2.401 times 10 to the 11. Good? here's the dimensional analysis I talked about. At first, it's gonna seem strange. In a week, you're gonna love it. Okay? Because it basically allows you to solve a problem when you don't know what you're doing. Okay? Okay. Dimensional analysis, first thing you have to do is look at where you're starting. In dimensional analysis, we're going to move, okay? We're going to move from left to right on our board, we're going to move left to right on our paper, we're going to move, okay? You have to figure out what we're given in our problem that represents our starting point, okay? And then there's going to be relationships between things that we can use to convert. These are conversion factors, okay? Basically what it allows us to do is if we have to get from point A to point C, but we don't know how A is related to C, but we know how A is related to B, and we know how B is related to C, we can get from A to C, okay? So we look for where we're starting, what relationships we have. If they're complicated relationships, the problem will give them to you. If it's a simple relationship like meters and centimeters, you have to know that, okay? How many centimeters are in 1 meter? 100. 100 centimeters in 1 meter is 1,000 millimeters in 1 meter, okay? So we're gonna set up a problem, you're gonna get an answer, okay? Like I said, you can do this math without knowing what you're doing. But you're gonna get an answer, and you have to look and say, does this make sense? Okay? If question wants you to calculate the volume of an ant, okay, and you get that the volume of the ant is 800 liters, something's not right, okay? Or you need to be running.
Big ant.
Okay. There are 2 methods to do this. I suggest using this grid method, okay? I use a grid method. I'm in lab, say today, and I need to do dimension analysis, I write out these grids, okay? Don't be too proud to use a grid, okay? On the slides, they don't use grids, okay? These slides are from textbook, they didn't use grids. If I used grids and went through and changed everything to grids in the entire semester, I wouldn't finish until I was retiring, okay? These grids are really hard to do on PowerPoint, and they come out exactly the same, okay? There's this grid method. And if I go to another, I'm coming back to this. I'm trying to find the other example of the other method. That. So this is the other method, okay? It does the same exact thing. Use whichever one works best for you, and we'll see how they work. But use whichever one works best for you. To me, that is a lot easier to do than that, okay? So, give me 30 seconds, and I'll get back to the slide I'm trying to get to. Okay, so our problem is to convert 2 inches to centimeters. And we're told that 1 inch goes 2.54 centimeters. Okay? So what, in this problem, what would you say is our starting point? 2 inches. Okay? So I am going to write 2 inches. Okay? And then the first thing to do is to write a grid. Okay? Generally, this bottom left one stays empty. Okay? The only time this is not empty is if you have if you're starting with something that has 2 units like grams per cubic centimeter, and that's actually the last couple of slides that I took out. You don't have to do that kind of conversion. Okay? So for you, this box will always be empty. Okay? And the next thing you do is you look at the units that are here, and you automatically write the unit, same unit there. okay? You didn't have to think about anything. You didn't have to think what's going on. With the bet unit, you put it there, okay? And now you say, what relationship do I know that can help me convert from inches to centimeters? And in this case, that relationship is 1 inch equals 2.54 centimeters, okay? So, in our grid, a horizontal line means equals, okay? That says 1 inch equals 2.54 centimeters. So I'm going to say 1 inch equals 2.54 centimeters. There's the equal sign, here's the horizontal line separating them. Think of it this way. You know you can always multiply by a 1, and it doesn't make a difference, right? If these two things are equal, which it says they are, you're essentially going to multiply by 1. So the only thing that's going to change is your unit, okay? Yes, the number your calculator gives you is going to be different, but conceptually it's the same thing. It's a conversion. What you start with is equivalent to the end, okay? In our grid, a vertical line means multiply, okay? So once you have your grid, you look at the unit in the top right corner. The unit in the top right corner, when you do your math, is the unit you're going to end with. So, we're converting 2 inches to centimeters. What unit do we want at the end? Centimeters. So here we have centimeters at the end, which means we have our grid finished. Okay? So, what we do is we take everything on the top, multiply it together. In this case, there's just two numbers. So what is 2 times 2.54? 5.08, and then the long horizontal line means divide. So I put that there, and I multiply everything on the bottom, which in this case is just 1. Okay? What's 5.08 divided by 1? 5.08, and our unit that we finish with is centimeters. Okay? We know centimeters are our units because it was in the top right corner. Okay? When it gets longer, what you're going to have to do is cancel units as you go. Okay? If the same unit is on the top, is on the bottom, they cancel each other out. You can cross them out. Okay? And as you go, you purposely take that unit and put it there. So this cancels that. The inches go away, and you're left with centimeters. Okay? Later on, we're going to have these grids that go 4 or 5 boxes. So you're going to cross off units as you go, and eventually the only one you don't cross off is the one in the top right corner, which is why that is your unit at the end. Okay?
You still gotta do sig figs on this too?
Yes. Thank you. So, if you have 2 inches, convert to centimeters, how many sig figs do I need?
1.
1. So, if you write this on your homework, what would you write? 5 centimeters. Okay? So, in our grid, our 2 was our starting point. Each set that we use is a conversion factor. What's on top always has to be equivalent or equal to what's on the bottom. You use conversion factors one at a time to get your units from where you start to the units that you end. So if you're given a whole set of conversion factors and said to convert this to this, you can use your conversion factors like puzzle pieces. Say, I don't know scientifically what the heck I'm doing, but I can use my puzzle pieces and arrange them to get from the unit that I'm starting at to the unit that I'm finishing at. Okay?
Yeah.
That is correct.
Should be
Whoa,
5.
wait, no, that's horrible.
Yeah.
I don't know. I really,
We changed our definition to 6, but it should have said 5.08, and I thought I was all sorts of screwed up.
Yeah.
okay. So my guess is what happened is I probably changed the question and then forgot to change the answer. So, what is this really?
5 centimeters.
5 centimeters.
Is it better always to find the conversion with the 1 in the bottom? Like you wanna have the conversion like 1 inch
No,
equals
I
5
mean-
centimeters or 1 inch equals?
In this case, having a 1 on the bottom saved you some math because you didn't have to you divide by 1, you didn't have to do anything. Later on, you're going to have, if you have any number that's not a 1 on the bottom, you're going to have to do that math anyways.
Oh, so if it was like feet to inches, you put 12 in the bottom because it'd be inches and then the top would be feet. Right?
Right, right. That's a very good one. So if we convert 2 inches to feet, we put our inches here, we want to end at feet, so we go here. How many inches equal 1 feet?
12.
So there's 12 inches in 1 foot. And so now you can multiply 2 times 1 equals 2, 12 times nothing is 12. 2 divided by 12 equals 6. I don't know. 1/6, which is what in decimal form? Equals 0.16. How many sig figs do I need? 1. So that becomes 0.2 feet. By the end of the semester, you'll learn to read crooked.
So you can round the 16.
Right.
Yeah.
So you need 1 sig fig that's 6 rounded up. 0.2. So here's a longer one. Okay. We want to convert inches to kilometers. If you were at home or you were allowed to have your phone, you would look up a conversion factor between inches and kilometers. There is such a thing. But on an exam, there isn't. So we need to go step by step. Okay? So look at that problem. What is my starting point?
2 kilometers.
2 kilometers is my starting point. So I'm going to put 2 kilometers. Automatically, I'm going to put 1 grid. And before I even look at the problem, what goes here?
Kilometers.
Kilometers. Okay. Now I can look at my conversion factors. What do you think is a good first step?
Crossing out bands.
The 1,000 meter.
1,000 meters
Yeah.
equals 1.
So I'm going to use the last one. This one, 1 kilometer equals 1,000 meters. Okay? So, what unit's going to be here?
1,000 meters.
I'm going to put meters here, and then how many meters equals how many kilometers? 1,000 equals 1. Okay? What unit am I trying to get to in the end? Inches. Am I at inches?
Nope.
No. So I have to add another layer on. Okay? By default, that meters goes there. Okay? What's my next step?
Centimeters?
Meters to centimeters. Okay? So I'm going meters to centimeters. How many centimeters equals how many meters?
100.
100 centimeters equals 1 meter. Am I at my final unit?
No.
No. So I draw another one. By default, centimeters goes there. What's my next?
Inches.
Inches. How many inches equals how many centimeters?
1 inch equals 2.5 centimeters.
1 inch equals 2.54 centimeters. Am I at my final unit?
Yes.
Yes. Okay? So now I can make sure that all my units cancel. They're going to because I purposely did that as I went. So I can say meters, kilometers, cancel kilometers, meters, cancel meters, centimeters, cancel centimeters. All I'm left with inches. So I multiply everything across the top. And what do I get? 2,000 times 100. So you get 2,000, 200,000, then everything across the bottom is 1 times 2.54 equals what? 78,740. 0.15. So, what's my final answer? If you were going to write this on homework or on an exam, what would you write as your final answer?
80,000.
First you gotta find the sig fig,
Eight.
and then the,
78,740. Okay, so, how many sig figs?
One.
One. Okay. So, you can, so if you have one sig fig, what does this become?
80,000.
You have 80,000. Okay. You could leave it as 80,000, or you could change it to scientific notation. Either one would be correct. But, as it is, you're going to lose points.
you need inches in the back.
You need inches. Don't forget sig figs. Don't forget units. Okay? Either one will lose your points. Okay? Inches or units are a little easier to remember. Sig figs are more difficult to remember. Good. You have a question?
Wait, so you got the 78,000, and then you looked at how much they had?
I got 78,000, and then everything we did is multiplication and division, right? There was no addition and subtraction. So with multiplication and division, you look at how many sig figs you started with, and that's how many you end with. Okay? So we started with 2 kilometers. Okay? And how many sig figs does 2 have? 1. So our answer had to have 1 sig fig. So we took our nice, seemingly precise number and rounded it to 80,000. 80,000 has how many sig figs? 1.
So this is what 79.
If you put 79,000, you said? So if I put that, rounded that to 79,000, how many sig figs does that have? 2.
Oh, cool.
I can only have 1. Okay. And now you're gonna kill me for saying this, but conversion factors that you're given, ignore the number of sig figs in. Assume they have an infinite number of sig figs. Your sig figs are never going to be determined by the number in one of your conversions. Okay? So if it said how many inches are in 2.0 kilometers, you wouldn't say, well, here I used a 1, which only has 1, so my answer can only have 1. Okay? We call these definitions. It is exactly 1.
So you would just use the decimal, you would go by the decimals, not the sig figs?
No, so here you ignore sig figs here. You just look at what's in the problem itself.
Okay.
So 100 centimeters equals 1 meter, which equals 1.0 meters, which equals 1.000 repeating 0. It has an infinite number of sig figs. It is exactly 1. You can add as many zeros as you want. So that is never going to determine the sig figs in your answer. Look at the sig figs in the problem. Okay? So, Beth? This is their way of doing it. We said a vertical line is multiplying. I have a vertical line, they have a multiplication sign. I said a big long horizontal line is dividing. Here they're dividing. I said the top always has to equal the bottom. That's the same thing they're doing here. Taking 2, multiplying it by essentially 1, they're equal to each other, equivalent to each other, times a 1, times a 1. They're not changing anything, math or conceptually, they're not changing it. Everything is always equal to each other as you go along. So whichever way works best for you, go ahead and use it. Okay. Here's another example. What is the volume of a 14-pound block of gold? What is this question asking for? In units.
Grams per centimeter.
Where, this is, what is the volume? What is the good unit for volume? It says it's a block of gold, so it's a solid. What's the unit we would use for volume of a solid? Cubic centimeters, which the hint is cubic centimeters in one of these conversion factors. Okay? So, in the end, we want to get to something in cubic centimeters. So, you're looking at that problem. What is our starting point?
14 pounds.
14 pounds.
So that means, when we do our safe bid, we should have 2.
Correct. When we get to the end, whatever we get, whatever our calculator tells us, we have to tell it, no, you're wrong, we need 2 sig figs. Okay? So we have 14 pounds. I draw a grid, what goes here?
Pounds.
Pounds. Okay. Now we look at what we're given. What conversion factors can we use to help us get from pounds to cubic centimeters, where we're trying to get to? So what's going to be our first step? Right. So we can go from pounds to grams. I would do that first. Okay. So the pound is here. What's here?
Grams.
Grams. What number goes here? 453.6. What number goes here? 1. Are we at our final unit?
No.
No. So I add another one. By default, gram goes there.
1 centimeter cubed.
So
Goes up top.
19.3?
19.3 grams, 1 centimeter cubed.
So 19.3 at the bottom.
1 centimeter cubed.
I can't tell if what everyone's telling me is the same or if they're different.
1 centimeter cubed is at the top and 19.3 grams at the bottom.
Yes. Okay. Do you want to explain how you got that? Nope. You told me. I think you said it right. I wrote it
Well,
wrong.
the density is given, and the density is 19.3 grams. If you're trying to cancel out everything.
Right. So just by units, you can do this to cancel out your gram and get the cubic centimeters. But you can only do that if that's a valid relationship. Okay.
If you're trying to cancel out the grams.
So we're told
That's how you.
that the density of gold is 19.3 grams per cubic centimeter. That means, in words, for every cubic centimeter you have 19.3 grams, which means 1 cubic centimeter equals 19.3 grams. Okay? So you was given this conversion factor, but it was not written out as 1 cubic centimeter equals 19.3 grams. You had to do a little bit of thinking there, right? You had to stop and say, what is the meaning of the unit grams per cubic centimeter? Here is another one. Dan runs 6.5. This is the one I changed. There was a heck of a tough problem here before. You don't want it. You can look at it. Go ahead and do it. It's one of those ones that you don't start with an empty spot down here. Okay? You won't be asked to do that on the exam or anything. So, here's a new problem to replace it. Dan runs 6 5Ks per year.
Mine
How-
doesn't say that.
Right, so I deleted the problem that was in there and wrote this one here. So, Dan runs 6 5Ks per year. How many inches is this? Okay? The only conversion factor you're given is that 1 meter equals 1.09 yards. The rest of the conversion factors you have to know. So, where am I starting at?
Five,
plus
six,
one.
5K?
6 5Ks. Okay. So, what unit goes here?
Okay.
5Ks.
The 5K.
In this case, 5K is my unit. Okay? So I'm gonna put a 5K here. Now, what am I gonna, what relationship am I gonna use here? What can I do? You have a question? Sorry?
Okay.
5K is 5 kilometers.
Yes. So, 1 5K equals 1,000 kilometers, right? That's what 5K means. Okay? Now, you could probably skip this step by looking, if you run 6 5Ks, you can probably multiply 6 times 5,000, right? If you can do that, you can skip these steps, yeah.
1 5K should not be 1,000 kilometers.
Thanks.
That's 5,000 meters.
You gotta keep me on track.
Okay, 5,000 meters.
Just because I have a degree doesn't mean I'm always right. Is that correct?
Okay.
You sure? Okay. So, a K, the K in 5K means kilometer, right? And you're 1,000 meters in a kilometer. So in a 5K, there are 5,000 meters.
So we're gonna put the end in, just continue on that.
There is an N.
So should there be a 6 in that column to the left?
Yeah, well, 6 go, then we leave.
No, we'll include it when we do the math at the end.
30 times 5,000, 30,000 times 5,000.
No,
Yeah,
5K
what
is
do
a
you-
unit, 5K is a unit.
5K is gonna cancel out.
5K is a unit, so
Okay.
it's different, it's not
Yeah.
included.
So our 5K cancels our 5K, our meter cancels our meter. What's gonna go here?
Okay,
Yards.
30,000.
Yards.
Oh.
We're given a relationship between meters and yards. We can go meters to yards. How many yards?
1.09.
1.09 equals how many meters?
One.
1. Now what? We're not given anything else. Right. So we know yards goes here, and we know you can either go yards to feet, and then feet to inches, or if you know how many inches are in a yard, you can go straight there.
36.
So there are 36 inches in 1 yard. Okay? Now you can do your math. So what is the number on the top?
30,000.
Even?
Yeah, 5,000 times 6.
No.
If there's
Times 1.09 times
Oh.
36.
Okay.
It's a big number.
1,177,200.
100, I got 1, 1.
1177200.
So what are we multiplying?
So this is 6 times 5,000 times
Okay.
1.09 times
I thought
36.
we was gonna break it down.
And then on the bottom, we have 1 times 1 times 1
Mhm.
equals 1. So we have 1177200 inches. Is that correct?
No.
No, why not?
6 is
So you have to do the sig fig.
Sig fig.
1 6.
1 sig fig. So that is 1000000 inches.
No. No.
Yep. Yep. Because the
That's the one you
one
got round
doesn't
down.
round up to a 1. So
Okay,
you're doing
so
one
we'll
sig
round
fig.
down.
Yeah.
Gotcha.
Yeah.
So you're gonna round to this place. That 1 rounds down. Everybody see that? At least minus the whole 5K fiasco.
Does it show us how to write it in, just in case they ask us to write it in scientific notation?
this does not say that, but if you were going to write this in scientific notation,
That was
what would it be?
1 point, no, just 1.
1,
Times
10 to the
10 to
sixth.
the
6.
1, 2, 3, 4, 5, 6.
So would either one of those answers be correct?
Either
Yeah,
that
we
one,
get asked that.
either that one or that one would be correct. That, with a decimal point there is wrong. Right?
Yeah,
Because
that
that
would
makes
be
all these
2,
zeros
6.
significant.
No.
Okay, so this is one of those cell phone things. So go ahead and on your own, try to figure this out. And then I will make sure this is active online. And then you can text 31035.
If our num- are we
Sorry?
just doing it randomly, right?
So 31035 space and then your answer in number form to that number. Or you can go to polev.com/chem1030. I guess you have to create an account and you can submit it. If you don't have a phone or if it costs you money to do it, don't worry about it. Okay?
What does BO mean?
This the
128 milligrams.
You did the question.
Oh, okay.
Yeah, so the question up here is different than the one on your, in your
Okay.
slides.
But that's
You're doing this one. You're doing this one. Yeah, the one on there was a lot harder. Yes.
How many days do you
Question. So assume there are 365 days in a year, ignore leap years. If I were doing it with leap years, I would say 365.25 is all. Yeah. But we'll just ignore it. Does anyone know why you would take a baby aspirin every day for 50 years? And also, I do cancer research, that's what I do. And more it's becoming very clear that if you can reduce inflammation long-term, that you really reduce your chance of cancer. So pretty soon, they're going to be suggesting taking baby aspirin or ibuprofen, something like that, daily to reduce your chance of cancer. Aspirin is incredibly safe as long as you don't take so much that you give yourself ulcers. Other than that, you can take it.
numbers, space, then.
Then your number, then your answer.
This won't charge our phone or anything? I wasn't here when we first started.
Sorry?
This won't charge anything to our phone?
No, other
Okay.
than what it may cost you to send a text.
Oh, okay.
But no, it will not charge you anything. Does that mean somebody got the right answer?
Surprised you're done.
We're texting to the last number.
Right, so you send it to 37607 and you send 31035 space and then your answer. How many still working? Well, I mean, it wouldn't take me very long to do it, so.
It says, this may cause charges on your mobile account.
So,
I don't have any service.
See, take a peek and see if anyone.
the website's not coming up, or what?
There's a lot of charges.
You look at the website.
I don't have any service, so.
So what's the right answer?
That one looks correct, huh?
Wait, those are the answers?
That's what people send in. Who wants to, does anybody want to go up and do it on the board? Go ahead.
So this is what I was jacked up, so. I have no excuse me. Okay. Okay, to start with. No, I have a quiz. Can you see it? No, no.
Is that the same marker I was using?
No.
No. Same?
grams, right? Yep, yep.
There's, a milligram is 1,000 milligrams.
1,000 of
There's
grams.
1,000 milligrams in 1 gram.
So this is what I did, I times, this 5,000 to get, 81,000 grams. And then, I did this. I got it. This. And then I did here. No, yep. So, can somebody do 29 times 365?
10,585.
10, what?
585.
10, 1
There's a
zero?
5 at the end.
Okay.
So, I don't have these, actual answer up here. Well, most people got 5 to something, so I'm pretty sure that's probably correct. Most of what you did here is correct, I think. You were, unfortunately, you started off on the wrong foot
Yeah.
with here. So then you
So-
made everything more difficult.
So what?
So what I would suggest is when you do it this way, you lose track of where you are. At least I do.
Okay.
So if you use dimensional analysis, this is one of those ways I said, you can do dimensional analysis to find an answer when you have no idea what you're doing.
Can you do it?
Yeah. So I don't want to hold you up too much, so we're going to go through this
I'm sorry if I
quickly,
can't
we're going to
remember.
make a quiz. But what I would do, I'll just do the units, and the numbers are easy. I would start with the 50 years.
Okay.
actually. So I would say 50 years, and then I would do years to days,
Okay.
days to, you could do straight from days to milligrams if you wanted. The
I'll give
The
you
more-
days.
the less,
It just
the,
won't
I don't know what the word I'm
cancel.
looking for. The not skipping a step way is to go days to aspirins. So 1 day is 1 aspirin, okay? And then 1 aspirin
Is 81 milligrams.
equals 81 milligrams, and then you can go milligrams to grams, and then grams to ounces.